One, teaching you guys biology, and two, chocolate cake. In no particular order. So the other day, I bit into this oh so soft chocolate cake from Starbucks, and someone inside me was saying, "Oh my god, that's the best chocolate cake ever. You really should have more of that." That someone was also moving the muscles in my mouth so that I could chew that yummy piece of cake and finally swallow it even. This someone is the central, integral, most important, most prominent and talked about part of what we call the nervous system. Let me introduce you to the brain. So to define the nervous system in just one line, it's large and in charge. It's made up of billions of very special cells called neurons. And why are they really special? That's because they're not found anywhere else in the body. And these neurons bundle up together and form nerves. So information like, say, the glorious taste of cake travels super fast through the nerves to the brain and help the brain take important decisions like have more of that cake. Both you and I are wide awake, right? I'm assuming that you're awake now that you're listening to me. So here's something really interesting. We are individually producing enough electricity to power a small neon bulb. Now that's something you should actually think about. Coming to what neurons look like. They look like typical cells. They have a cell body. They have a nucleus. But if you think about it, they look similar to a tree with the branches, the trunk, and the roots. The branches are the dendrites. The trunk is called the axon, and the roots are called the axon terminals. Terminal. Have you heard about the word terminal before? What happens in a train or a bus terminal? Trains or buses come in and go out, right? Similarly, at the axon terminals, information in the form of electrical impulses will pass from one neuron to the other. They actually high jump across from one neuron to the other through the small space called the synapse. The axons in some neurons are covered with a sheath. It's called a myelin sheath. And what the sheath does, it gives insulation to the neuron. And the myelin sheath has to be made up of cells. I mean, everything inside us is made up of cells, right? And these cells also get a name, Schwann cells. And there is a depression between two Schwann cells that you can see. It's called the node of Ranvier, named after the person who discovered it or found it, for the first time. There are two main components or parts to the nervous system that we'll actually learn about. One, it's called the central nervous system, and everything else, which is the peripheral nervous system. So what is the central nervous system? You might have guessed it already. The main parts, the brain, the spinal cord, and they are responsible for something major. They are responsible for taking all decisions and thinking and telling. The peripheral nervous system, that is made up of nerves that branch all through the rest of our body. What needs to be done? And then the peripheral nervous system does it. So the nervous system now is central to our existence. It makes us who we are. It makes us do what we do. So let's start with the big picture. And nothing is a bigger picture than the brain. So what does your brain look like? Something like this. It has two distinct halves, the left and the right hemispheres. And information actually travels across both sides of the brain through something called the corpus callosum. Now, why is it important that information travels? Well, every side of the brain has its own sweet and special function. And very interestingly, pretty much the opposite function. For example, the left side of the brain, that is the left hemisphere, deals more with speech or verbal communication. The right with non-verbal communication. understand it depends on which side of the brain is more dominant for you. A. But note that that doesn't make you more or less positive or negative. This is actually completely theoretical. Scientists are still working really hard trying to understand emotions. In fact, research says that to bring out the maximum creativity in you, you should maximize usage of both sides of your brain. So let's do one thing. Let's do a little exercise together. Let's try to build on your creativity. Try brushing your teeth or combing your hair with a non-dominant hand. In most cases, like me, that would be the left hand. Now, if incorporated into your routine, it can help stimulate the creative part of you. Now, let me show you something really interesting. If you draw the eyes over here, okay, and now you look straight ahead. So, whatever is on the left side of your vision actually goes to the right side of your brain. Okay? And whatever is on the right side of your vision actually goes to the left side of your brain. So let me give you an example. Say I show you this flower here. You can see it's on the left side of your vision. And I'll ask you a question. What did you see? What you saw actually moves from the right side of your brain down to the left side, which is responsible for speech. And that's when you can actually reply and tell me, hey, what I saw there was a flower. Now, if you cut open the brain vertically, I know it's a really gross thing to do, but if you do that, you would actually see 4 distinct clear parts. Part number 1, the cerebrum, which forms most of the brain and is responsible for all our senses. What are our senses? Yes, sight, smell, touch, taste, hearing, all of that. Even our imagination and all our thoughts. Next, the cerebellum or the little brain is, well, the reason why we're able to walk or cycle without falling. It's responsible for our motion, our balance. You're actually able to learn salsa and impress that girl next door thanks to your cerebellum. It's responsible for helping us learn new things. Moving on, there are so many things happening in your body without you consciously having to think about doing those things which your body does. It's actually really simple. Let's think about it this way. Once you have that yummy piece of chocolate cake, digestion is something that happens on its own. I don't think you do anything about it, right? Similarly with breathing, your heart beating. You don't need to think about doing these things consciously. They happen and they keep you alive. Now who's responsible for that? The medulla oblongata. So now you know whom to thank for all those everyday essential things that you don't even have to think of. So all these parts of the brain that we spoke about are really important and they're also very, very delicate. So it needs to be specially packaged in layers of membranes called the meninges. And we also add on a shock-absorbing liquid called the cerebrospinal fluid. And to finish off this packaging, we have our skull or the cranium, which gives our delicate, fragile, and oh so important brain all the protection it actually needs. So I told you that these special cells called neurons are bundled together and they form nerves. You have 2 types, cranial nerves and spinal nerves. So what is the difference? The name actually tells you all. Cranial nerves arise from the brain and spinal nerves arise from the spinal cord. Even neurons are classified into 2 types, afferent neurons and efferent neurons. Afferent neurons bring messages to the central nervous system and efferent neurons take messages away from the central nervous system. Now both these types are terribly important and horribly confusing, but I'll also give you a simple trick to remember it. You already know that about having more cake is relayed back through the motor neurons or the efferent neurons, which then move the muscles in your body so that you can take another bite of that delicious cake. Efferent neurons get a special name called motor neurons in the peripheral nervous system. You need to think about why it's called motor neurons. That is because it ends in muscular cells, where there is movement involved, where information travels or passes between the nerve cells and the muscle cells through chemical reactions. So this brings about the much needed movement in our body that keeps us alive. So now, based on what we discussed till now, you must be thinking that the brain is the almighty organ that takes each and every decision for us. Well, not so all the time. When you need to take decisions really fast, like when you touch a hot stove, afferent neurons in your hand carry the signal hot, hot, hot to the central nervous system, and the spinal cord sends a message back quickly to the efferent neurons in your hand and says, get your hands off that stove or you could possibly get burned. So in situations like this, where you actually need to take a decision really fast, the spinal cord comes in handy, takes the decision for you so that you actually don't get burned and that we're all safe and sound. You can give me more examples for reflexes. Supposing someone flashes light in your eye, then you would automatically close it, right? This is called the reflex loop or the reflex arc, which really actually comes in handy when situations arise where you can get your hands possibly badly burnt. Now, the spinal cord also comes with its own special packaging in the vertebral column, which runs down your back. Now, if the story of the nervous system ended here, life would not be as complex as it actually is, and we would not be able to do the millions of things that we actually do, or think the zillions of things that we actually think. So we spoke a lot about the central nervous system. What about the rest? The peripheral nervous system. Now, the peripheral nervous system also has two different systems. One is called the somatic nervous system. The other one is called the autonomic nervous system. Hold on to the names, we'll get there. Let's start with the somatic nervous system. It's actually responsible for all the actions we think about doing and then the body does it, like when you want your body to make a nice dance step when you groove to some music. And then it does it. So you think about it, it happens. That's the somatic nervous system for you. That was pretty simple. Now, what about the other part, the autonomic nervous system? It's not as simple. You've got two more divisions out there, the sympathetic division and the parasympathetic division. Not just different, but completely opposite to each other. And there's this constant battle or game going on in your body as to who should get control when. So the sympathetic division is whom you should hang when you're being chased by a 15-foot dinosaur. This is activated when you're under stress. It's also commonly called the fight or the flight response. So what it does is that when you're chased by that dinosaur, it increases the blood supply to your lungs and muscles, dilates your pupils, activates your adrenal cortex to make more adrenaline, increases your heart rate and BP, reduces blood supply to digestion and reproductive system so that more blood is available for your muscles and lungs so that you can run. This system is always switched on and available, although I really sincerely hope that you're always not in a perennial state of panic. Now, what about the opposite? When you're safe back home in front of the TV. That's when the parasympathetic division takes over. Helps you take life nice and easy, reduces the heart rate, makes your nose run, constricts your lungs, helps your mouth produce saliva, helps you visit the bathroom, have a nice nap, and so on, so on, so on. So let me put this across in a very simple manner. The sympathetic division is responsible when you freak out, and the parasympathetic division is responsible for really chilling out and having that response. So both of these work side by side. It's like a balance, and so it does give you that balance in life. This situation is called homeostasis. they look like. Remember I told you they look like trees? Yes, very similar, right? And what do? They carry information through electric impulses all through your body. So the in charge part of the nervous system is the central nervous system, and the executive part of the nervous system is the peripheral nervous system. Again, the central nervous system has two parts to it, the brain and the spinal cord. So the important diagrams you will need to know from an exam point of view. One is definitely the brain, looks like this. Now each part of the brain has its own special function. You can look at the functions. It's always open to our senses. The brain definitely makes most of the decisions for us, unless the decision has to be really, really quick, like in a spinal reflex arc. In that case, the decision is taken by the spinal cord itself. This brings us to the third important diagram that you need to know, the spinal cord. Also, we have two types of neurons. Do you remember the names? Sensory or afferent neurons and motor or efferent neurons. Remember the A and the E? So sensory neurons are the neurons present in the peripheral nervous system. They have specialized endings. They end in sense organs. Motor neurons are those neurons that typically end in our muscles to bring about movement when the central nervous system instructs them to make a movement. So the information travels from the neuron to the muscle through this special place that has a very obvious name. Remember, it's between a neuron and a muscle, so it's called the neuromuscular junction. Really simple, right? So that's all there is to it. I'm sure that is really, really simple to you now. A very, very important part or important section, topic, simplified to an extent, where you just need to connect all the functions to what actually happens in our day-to-day life. I'm sure it's going to make the learning very, very easy.